Welcome to the deep dive, where we unpack cutting edge research and stuff. Today we're diving into AI and a fascinating new approach to memory for AI.
Yeah, we're going to be exploring a paper from NeurIPS 2024 called HippoRAG, Neurobiologically Inspired Long-Term Memory for Large Language Models. So this research is all about giving LLMs, your ChatGPTs and BARDs and all those, a more human-like way to remember and connect information.
Okay, this sounds pretty interesting. It could be a big step forward. So what's the main problem they're trying to solve with HippoRAG?
Well, current LLMs, they're good at retrieving stacks,
Yeah.
right? But they struggle to truly understand and integrate new information. They don't have that aha moment that we experience when we connect ideas from different sources.
Right, so they're kind of missing that ability to build that web of understanding that we get with our own experiences and knowledge.
Yeah, and the researchers behind HippoRAG, they drew inspiration from the human brain for this, particularly the hippocampus, which acts like a librarian for our memories.
Interesting. So how does that translate into building a better memory system for AI?
Well, in HippoRAG, they try to mimic the hippocampus function in two phases. So first you have offline indexing, where an LLM reads through your sources and extracts key concepts and relationships to build what they call a knowledge graph.
So it's not just memorizing a text, it's creating a map of the information,
Hmm.
highlighting the important landmarks and how they all connect.
Yeah, that's a great way to put it. And then there's the online retrieval phase, where when you ask it a question, it uses the concepts from your question to activate related areas of this knowledge graph, which enables what they call multi-hop reasoning.
Ah, okay, so this is where it gets really interesting. It's not just searching for keywords, but it's understanding the connections between pieces of information.
Right. And to give you an example, you could ask it, which Stanford professor researches Alzheimer's? And even if no single source explicitly states both of those facts, HippoRAG can still find the answer by connecting those dots within its knowledge graph.
Wow, so it's it has this deeper understanding of the topic.
Exactly. And the research highlights that this makes it 10 to 30 times faster and cheaper than current methods, which require multiple steps to get to the same answer.
That's incredible.
Hmm.
And it also means that the system can continuously learn by adding new information to the knowledge graph without needing a full retraining.
Right. It's constantly updating and learning.
So we're really talking about AI that's less like a search engine
Yeah,
and more like a research assistant that can actually synthesize information.
exactly.
And one thing I thought was really intriguing is that they used GPT 3.5 Turbo to build this knowledge graph, but they also found that open source LLMs like Llama could work too.
Yeah, that's one of the interesting things about it. It could potentially be more accessible and widely applicable than you might think.
That's great. So are there any specific examples from the research that demonstrate how this works in practice?
Yeah, so they tested HippoRAG on a few multi-hop question answering data sets. And one example that they give is trying to find the answer to in which district was Alejandra born? When that information is spread across multiple documents.
Okay, so that seems like a pretty simple question on the surface, but it highlights how challenging it is to connect information from different sources, something that trips up a lot of current AI systems.
Exactly. Traditional search methods would really struggle with something like that, but HippoRAG excels in this area.
So during that offline indexing phase, it created the connection between Alejandra and their birthplace and the district. And then later on, it can retrieve that information, even when the question doesn't explicitly mention the birthplace.
Right. It's all about making those connections beforehand.
It's like having a detective working behind the scenes, piecing together all the clues.
Yeah, I like that analogy. They also talk about a concept called node specificity.
Okay, node specificity. What is that?
So essentially, it's a way for the system to prioritize certain nodes in the knowledge graph based on how frequently they appear. And this helps HippoRAG focus its attention on the most relevant information.
So it's like a built-in relevance filter
Yeah.
to cut through all the noise of less important details.
Exactly.
And they also use synonymy edges
Yeah.
to connect similar concepts, even if they aren't explicitly stated as synonyms.
Right, because sometimes different words can refer to the same thing. And it's important for the AI to understand those nuances.
Yeah, that seems really crucial for understanding the subtleties of language.
Absolutely.
The paper also mentions the personalized PageRank algorithm in HippoRAG's online retrieval process.
Oh yeah, personalized PageRank or PPR. It helps HippoRAG to efficiently explore the knowledge graph and identify the most relevant subgraphs based on the user's question.
So it's kind of like a GPS for the knowledge graph.
Yeah. It guides the system to the right area of the map to find the answer.
And that's what makes it so efficient.
Exactly. It doesn't need multiple steps to find the answer.
Okay, so they found that HippoRAG could achieve comparable or even better performance than these iterative methods, while being significantly faster and cheaper.
Right, and this is really important, especially when we think about real-world applications, where speed and cost are critical factors.
Yeah, absolutely. Can you walk us through a specific example of how this works in practice?
Sure, so let's look at the example of a path-following multi-hop question from the music dataset. The question is, in which district was Alejandra born? And the challenge here is that the answer is spread across two different passages.
Right, and this is where traditional search methods would likely fail.
Exactly. So one passage mentions Alejandra's birthplace, but it doesn't mention the district.
Mhm.
And then the other passage mentions the birthplace and its district.
So the system has to connect these two pieces of information to answer the question.
Right. And during the offline indexing phase, HippoRAG extracted the relationships between these pieces of information so that during online retrieval, when using the concepts of Alejandra and district, it activates the relevant part of the knowledge graph and can arrive at the correct answer, which is Lisbon.
It's like putting together a puzzle and finding that missing piece that connects everything.
Yeah, exactly. And they also discuss the limitations with traditional retrieval methods when it comes to path-finding multi-hop questions, which are even more challenging.
Okay, so what makes these path-finding questions so challenging?
Well, they require finding a connection between two concepts. When there are many possible paths to explore, it's like navigating a maze with multiple routes.
Right.
And they give the example, which Stanford professor researches the neuroscience of Alzheimer's.
I see. So there are multiple starting points and numerous possible routes to the answer.
Exactly. And traditional methods struggle with this because they're not designed to explore multiple paths simultaneously, so they may miss the connection entirely.
Whereas HippoRAG,
Yeah.
with its knowledge graph and BPR algorithm, can explore those multiple paths efficiently.
Exactly.
So it increases the chances of finding the right answer.
Right. And they provide more examples of these pathfinding questions in the paper, highlighting HippoRAG's potential in tackling this challenge.
It sounds like this is a pretty significant leap forward in AI's ability to handle this kind of complex information and answer these intricate questions.
Yeah, it has the potential to be a real game changer. They also point out some limitations with HippoRAG and areas for future research.
Okay, so what are some of those areas where this technology could be further developed?
Well, one thing they note is that their current implementation relies on existing components for named entity recognition, or NER, and open information extraction, or OpenE. And these components can sometimes introduce errors.
So there's room for improvement.
Yeah.
In terms of fine-tuning those components for greater accuracy.
Right.
So that would further enhance the performance and reliability of the system.
Exactly. And they also mention that the scalability of HippoRAG to very large knowledge graphs needs further investigation. As the knowledge base grows, it's crucial to make sure that the system remains efficient and accurate.
Yeah, scalability is key, especially if we want to apply this to massive data sets in the real world.
Absolutely. And they're also exploring ways to incorporate more contextual information into the knowledge graph.
Right, because just having the concepts might not be enough.
Exactly. And finding that right balance between concepts and context is crucial for achieving a truly human-like level of understanding in AI.
Okay, so that's a key focus for future research.
Yes, definitely.
This is all really fascinating stuff. It's exciting to see how this research could lead to breakthroughs in how AI understands and interacts with information. So let's delve into that more in the next part of our deep dive. We've been talking about how HippoRAG takes inspiration from the human brain, but I want to dive a little deeper into that analogy. How does it actually mirror the way we learn and form memories?
Well, the paper goes beyond just mimicking the structure of the brain. It explores those underlying principles of human learning and applies them to an AI system. So they talk about pattern separation and pattern completion as being crucial processes.
Okay, pattern separation and pattern completion. Those sound pretty complex. Can you break those down for us?
Sure. So pattern separation is how our brains distinguish between similar experiences. It prevents our memories from becoming like a jumbled mess. For example, it allows you to remember your first day of school distinctly from your second day, even though they share many similarities.
Right, so it's like creating these clear distinctions between memories, even if they're closely related.
Exactly. And then pattern completion is what allows us to recall a complete memory from just a partial cue.
Oh, like recognizing your childhood home from just a glimpse of the front door.
Exactly. And these processes help us build this rich network of interconnected memories, which is what HippoRAG is trying to replicate in an AI system.
So how exactly does HippoRAG achieve this?
Well, they use this analogy of the neocortex and the hippocampus. So the neocortex, which is responsible for processing and storing sensory information, is represented by the LLM in HippoRAG. And then the hippocampus, which acts as an index for our memories, is represented by the knowledge graph that's built using OpenIE.
Okay, so the LLM is absorbing all that raw information. And then the knowledge graph is creating the connections between those concepts.
Yeah.
Similar to how our brain organizes memories.
Exactly. And the paper also talks about these parahippocampal regions in human memory, which kind of bridge the neocortex and hippocampus and help to filter and organize information.
So what part of HippoRAG is performing that function?
So in HippoRAG, retrieval encoders play this role. They link similar concepts in the knowledge graph, even if they aren't explicitly stated as synonyms. So it allows the system to understand those nuances of language.
So they're kind of like refining the information, making sure that similar concepts are connected, even if different words are used, like a team of editors ensuring consistency.
Yeah, that's a good way to think about it.
So by mimicking these crucial components and processes of human memory, HippoRAG aims to create this really robust and adaptable form of long-term memory for AI.
Right.
And how do they actually evaluate the effectiveness of this approach?
Well, they tested HippoRAG on multiple challenging multi-hop question-answering data sets, and they found that it significantly outperformed existing methods in both accuracy and efficiency.
Okay, what kind of data sets are we talking about here?
So they use data sets like music and 2Wiki multi-hop QA, which are specifically designed to test multi-hop reasoning.
So these are data sets where the answers aren't explicitly stated in one place, but require you to connect information from different sources.
Exactly. And they highlight this all-recall metric, which measures how often the system retrieves all of the necessary passages to answer a question.
Okay, and why is that metric so important?
Well, it's particularly crucial for multi-hop questions because it shows that the system can actually integrate information effectively.
So it's not just finding some of the relevant information, it's gathering all the necessary pieces.
Yeah.
And how did HippoRAG perform on that metric?
It showed significant improvement over other methods, indicating that it wasn't just finding some of the information, but could actually gather all the necessary pieces to answer the question.
That's impressive. It sounds like it's not just finding answers, but it's actually building a more comprehensive understanding.
Yeah, and they also compared HippoRAG to iterative retrieval methods like IRCoT, which is a really powerful method that uses multiple steps of retrieval and generation to answer these complex questions.
And how did HippoRAG stack up against that?
Well, HippoRAG achieved comparable or even better performance while being significantly faster and less expensive.
So it's not just about improved accuracy,
Right.
but also greater efficiency.
Exactly. And they also analyzed the errors that HippoRAG made during the evaluation and found that many of them were due to limitations in the NER and OpenE components.
Right, so there's still room for improvement there by refining those components to work more seamlessly within HippoRAG.
Exactly. And they also discussed something called the concept-context trade-off.
Okay, concept-context trade-off.
So HippoRAG's entity-centric approach sometimes misses important contextual information because it focuses so heavily on the concepts themselves.
Can you give us an example of that trade-off?
Sure. They mention a case where the system focused on the concept of protons, but missed the context related to the discovery of atomic numbers.
Right, so you can see how focusing solely on concepts could lead to missing important nuances.
Exactly. And to address this issue, they've been experimenting with combining HippoRAG with dense retrievers when there's uncertainty about entity linking.
So it's about finding that balance between concepts and context.
Right. Much like how humans process information.
And they also analyzed how OpenAI performance changes with document length.
Yeah, and they found that GPT 3.5 Turbo, which was their primary OpenAI model, struggled with longer passages.
Okay, so that's something to keep in mind. Future work might need to explore different OpenAI methods that are more robust to variations in document length.
Right.
And they also provide some details about HippoRAG's cost and efficiency compared to other methods. Yes. And what were the key takeaways from that analysis?
Well, they found that HippoRAG was significantly more efficient than iterative methods, both in terms of API cost and processing time.
Wow, so that makes it a much more practical and scalable solution,
Exactly.
especially as we move toward more complex and data-intensive AI applications.
Right.
So overall, it sounds like the researchers are pretty excited about HippoRAG's potential,
as a
A
more
robust and flexible approach to long-term memory in LLMs,
Yeah, they definitely see it as a significant step forward.
even though they acknowledge that there are still limitations and areas for future research.
Right, they're optimistic about where this technology can go.
It's exciting to see how this research unfolds and what new possibilities it opens up.
Okay, so we've covered a lot of ground here. But I'm curious about the practical side of things. Like, what did the researchers actually do to test and refine all these different aspects of HippoRAG? Well, they actually explored alternative approaches for some of its core components. Like, for example, they experimented with various OpenAI models, both closed source and open source.
And what did they find? Were there any notable findings from those experiments?
Yeah, well, they discovered that.
Yeah.
While GPT 3.5 Turbo performed well, open source models like Llama also showed a lot of promise.
Oh, that's really interesting.
Yeah.
Especially from an accessibility standpoint.
Yeah.
It opens up the possibility for a lot more people to experiment with this technology.
Right, exactly. And they also experimented with different methods for incorporating node specificity and synonymy edges.
And how did those experiments turn out?
Well, these techniques actually led to noticeable improvements in performance, which really underscores how important they are for capturing those nuances of language and how knowledge is represented.
So it's like they were fine-tuning the system to be more sensitive to the subtle ways that language works.
Right.
Now, you mentioned earlier that they delved into the potential of HippoRAG for this specific type of multi-hop question, pathfinding questions. Yeah. Can you remind us what makes those questions so challenging?
Sure. So these pathfinding questions involve finding connections between concepts, where there are numerous paths that could be explored. It's like trying to find the shortest route between 2 points in a vast network.
Right. And as we discussed, traditional retrieval methods really struggle with this complexity.
Yeah, they tend to only follow one path at a time.
Whereas HippoRAG, with its knowledge graph and PPR algorithm,
Right.
can explore multiple paths simultaneously.
Right.
That sounds incredibly efficient. So, did they give any examples of HippoRAG successfully answering these challenging pathfinding questions?
Yeah, they actually showcase several compelling instances where HippoRAG effectively answered questions that other methods couldn't.
Okay, so those real-world examples really highlight HippoRAG's potential for these scenarios where information is really fragmented and interconnected.
Exactly.
Now, I know you also mentioned that they did a pretty detailed analysis of HippoRAG's computational cost and efficiency.
Yes.
So what were some of the key findings from that analysis?
Well, they found that HippoRAG was significantly more efficient than iterative retrieval methods, both in terms of API costs and processing time.
Wow, so it's not just a theoretical advancement, it's a practical solution that could actually be applied to real-world tasks.
Right, and that's one of the things that makes it so exciting.
Yeah, absolutely. So overall, it sounds like HippoRAG represents a pretty significant step forward in how we think about AI and long-term memory.
Yeah, definitely.
It's a really remarkable example of how interdisciplinary research, combining inspiration from neuroscience and computer science, can lead to these kinds of advancements.
Absolutely.
And by drawing upon these principles of human memory, HippoRAG really offers a glimpse into a future where AI can learn and understand the world in a much more profound way.
I agree.
Well, it's been an absolutely fascinating discussion exploring this cutting-edge research on AI and memory. Thank you so much for joining us on this deep dive into HippoRAG. And to all our listeners out there, thank you for tuning in. We'll see you next time on The Deep Dives.